So I'm from Tufts University. I know there's a lot of Tufties out there hanging out. And I'm going to talk about something called the Open Geoportal. And the Open Geoportal, specifically I'm going to talk about Tufts' instance of it, which is called Geodata at Tufts. And Tufts is leading a sort of a collaborative effort with the two small schools down the road, Harvard and MIT. We're kind of coming together to build this platform. So what is this platform that we're working towards? Get my good definition here. This is the only time I'll read a slide. It's a collaboratively developed open source federated web application to rapidly discover, preview, and retrieve geospatial data with a heavy emphasis on rapid discovery. We really want to look at discovering data. It's also a new collaborative effort. So it's people coming together around application development, data sharing, data licensing, all around big geospatial data sets. Mostly curated, but of course we're going to have to start dealing with a lot of uncurated data as well. Let's take a look at the interface. On the right, you have a map interface, pretty typical. On the left, upper left, search box. And the lower left is a search results. It's empty right now. We're going to run a search here. We'll run a search just on a global extent with no keywords. And you'll see some results populate here. So here we have over 9,000 publicly available data sets, geospatial layers. On the right there in the lower red, you'll see the different repositories. It's streaming data from all these massive geospatial repositories. As we zoom in on the map, we'll zoom into Kenya. And as we zoom into Kenya, you'll see that we automatically drop the search results to 400. And then Kenya data layers are immediately cascading to the top. This is a pure spatial search right now. There's no text involved at all. So pure spatial, as you zoom in, Kenya data's cascade. As we go to Afghanistan, you'll see the same thing. Afghanistan layers come up. If I mouse over that land cover Afghanistan layer, you immediately see the bounding box, the geographic extent. That's usually the first instance or first thing one wants to see with geospatial data is the extent. Now we'll zoom in closer, and here we're going to zoom into Jerusalem. So we'll see more urban-based data sets here. Right? These are more detailed data. There's still 400 some odd results in this geographic area. So we'll qualify that with a keyword search. So here we'll add something like buildings. So we'll add buildings. When you have buildings combined with the geographic area of Jerusalem, the first hit you get is Jerusalem buildings from 2008, I think. That's going through almost 10,000 data layers, searching through that. You can also preview the graphics if you want. So you can preview the buildings to see the actual buildings. You can zoom and explore them. You can also preview the attributes of an individual feature. For geospatial folks, we like that data that's attached to these graphics often. So you can preview the actual attributes. You can also do more advanced searching. So here we're doing a more advanced search tab. This we're searching. You can search by topic, keywords, year, data type, line, polygons, raster, that sort of thing. And then if you find some data layers you like, you throw them into your shopping cart, right? We're all used to shopping carts these days. So you throw them in your cart. Here you can download the layers if you want, shapefile, KMZ format. You can ship and clip. It'll clip the data sets to your geographic extent, which is really critical for some of these massive data sets that we're dealing with. You can also, if you hit the web services button, here you can generate custom web services, WFS, WMS. You can stream these directly into your desktop mapping applications or to your web mapping applications. We're really interested in publishing out data to other interoperability environments, so other web mappings. If you hit share, you can share your cart. Someone takes this, either an email or a web link, click on it, takes them right to this extent with all these data layers. It's a way of sharing massive data sets without actually sharing the data itself. You just throw them in your cart and share that out to people. Map it also will work eventually to other mapping environments. It's extendable and agile in this sort of Ajax-y way. You can expand all the search results, the map, all that sort of stuff to whatever your preference is. Regarding the sort of underlying technology here, I think the most interesting thing probably is all open source, probably our use of Solr and Lucene for our spatial searching and also for our keywords. It also makes this database independent. The reality is you have to be database independent if you're going to federate anything. Some of our partners, there's a whole slew, there's a lot more. These, in various ways, these are our partners we're working with. Data is from global to local, international to domestic, non-restricted, and some restricted data as well. We have some key highlights, things we just finished working on and moving forward on. One of them is our thesaurus. So our thesaurus is basically, we've mined over 30,000 metadata records, and we've found natural groupings of language. So we've done two different types of thesaurus. So now when a person searches roads, they actually get data sets that are cataloged as streets. Sounds really minor, but this isn't really minor, the way metadata is created. Also created a lightweight cloud-based metadata toolkit. People need to be able to create metadata within 5 minutes. Pulls from controlled vocabularies so that we actually know what we're populating in this metadata. We need to be able to do it rapidly. Finally, more interoperability with web mapping tools. We're almost done with all that. Tons and tons and tons of more data. New interface release. So come talk to me at the tech fair. We'll suck down cocktails and talk about publishing data and searching your data. Thanks.